In this video, we're going to be learning how to solve radical equations. So let's review. A radical equation is an equation that has a variable in the radicand or a variable with a fractional exponent. So for example, if I want to get rid of the square, then I would take the square root in order to get x back as the answer. If I had a square root of x, I would square the square root in order to get x as the answer. If I had 2/3 as the exponent and I needed to get to x, then I would raise it to the 3/2. I wouldn't multiply by 3/2. I would raise it to a power of 3/2 because 2/3 times 3/2 cancel each other, giving me x. So if I had the 4th root of x cubed, that's the same thing as saying x to the 3/4. Therefore, I would need to raise it to the 4/3 power in order to get x as my answer. So you're needing to you are needing to raise a variable to the reciprocal in order to get x back as the answer. For example, okay, again, a radical equation that has a variable in the radicand. To solve, you will isolate the radical on one side of the equation, and then you're going to raise both of them to the same power. Be careful, we have extraneous solutions in cases like these. So for example, how do you get rid of a square root? You would do the reciprocal of a square root, which is you would square both sides. The square root and the square cancel, leaving me 25. Be careful, this is not plus or minus 25. Only if you take the square root of both sides can you get a plus or minus. In this case, you are squaring both sides, and so your answer is only 25. And just to explain it, if I said that it possibly could be a negative 25, if I put negative 25 back in here, I do not get 5. I actually would get 5i, and so that is why you do not take the plus or minus in this case. Over here, it had told me to isolate the radical, and so I need to isolate this radical. So in order to get this by itself, I need to subtract 1 from both sides. So I'll get the cube root of x plus 2 equal to 8. Now, to get rid of a cube root, I need to raise both sides to the reciprocal. The reciprocal of cube root is a cube. They cancel, leaving me x plus 2 equals 8 to the 3rd. And 8 to the 3rd is 64 times 8, which is 512. Now to solve for x, I'm going to subtract 2, and I'll get 510 as my answer. Not plus or minus, just 510. So in order to solve these problems, we're still going to do the same thing. The radical is isolated, it is by itself, and so I'm going to get rid of the radical by squaring both sides. The square root and the square cancel, leaving me x plus 6 equals x squared. Now, the fact that we have a variable that has a square and an x means that it needs to be set equal to 0. So we need to get the x on this side, we need to get the 6 on this side. So we'll get x squared minus x minus 6, because we had to subtract the x and subtract the 6. This becomes 2 parentheses, x minus 3 and x plus 2. So therefore, x is going to equal 3 and x is going to equal negative 2. However, one of these does not work. If I plug 3 back into my original, by the way, I'm going to go ahead and put boxes around the possible answers. I have x plus 6 equals x. If I plug in 3, I'll get the square root of 9 equals 3. And the square root of 9 is 3. So it worked. Yay! That one worked. If I plug in negative 2, Negative 2 plus 6 is 4. The square root of 4 is not negative 2. The square root of 4 is 2. So therefore, this does not work. The square root does not give you a negative number. So this did not work. Only x equals 3 worked. In this case, we need to isolate this square root. So I need to get the 5 over on that side. So I'm left with x minus 3 equals x minus 5. Now, here's where it gets a little interesting. I need to square this to get rid of the square root. But when I square this side to cancel, I have to square the quantity of x minus 5. X minus 3 ends up on the left-hand side because the square root and the square cancel. But do not tell me that this is x squared minus 25. It's not. You cannot just square each part. This entire thing is squared, which means you have to write it twice, which means you have to FOIL, okay? So this FOILs into x squared minus 10x plus 25. Now set it equal to 0. When you subtract x, you will get a negative 11x. And when you add 3, you will get 28. This becomes x minus 4, x minus 7, because they multiply to give you 28, I had to give you negative 11. And so therefore x equals 4 and x equals 7. And then if you plug them back in, 4 minus 1 is 3. 4 minus 3 is 1. The square root of 1 is 1. 1 plus 5, oh, so let's actually try this. If I plug in 4, the square root of 4 minus 3 plus 5 equals 4. Let's see if that works. Square root of 4 minus 3 is 1. The square root of 1 is 1. Is 1 plus 5 4? No. That actually does not work. Now let's try 7 and see if that actually works. 7 minus 3 is 4. The square root of 4 is 2. Is 2 plus 5 equal to 7? Yes. So this happened again. One of these worked, one of these did not work. So you have to check for extraneous solutions each time. So in this case, we're going to do the exact same thing except with rational exponents. We need to isolate the rational exponent. So we need to get it by itself, which means we need to get rid of the 2. So we're going to divide by 2 from A and get 4. Now we need to get rid of this exponent. And the way to get rid of the exponent is we are going to raise the entire thing to the reciprocal, which is 3/2. That cancels, leaving me x minus 3. This is the same thing as the square root of 4 raised to the 3rd power. But you're actually taking that on both sides. So you will get plus or minus on this side, which is plus or minus 2 to the 3rd, which gives you plus or minus 8. So when you add 3, 8 plus 3 is 11. Negative 8 plus 3 is a negative 5. Now, I know you're probably wondering, why in the world did I put a plus or minus? In the past, when we had, like, forget about the 3 right now. Let's just look at the 2. Let's say we had the x minus 3 squared equals 4. How do you get rid of a square? We took the square root of both sides. And when you physically take the square root of both sides of something, it's always going to be a plus or minus because you took the square root of one side and the other side. So basically, here's the deal. If you have a numerator that is even, you will have to do a plus or minus. whenever you take the reciprocal. Because when you take the reciprocal, the even number becomes the root. And way back in section 1, we discussed that if a root is even, if you take the root of both sides and the root is even, you would get 2 possible answers. So, if the numerator, only the numerator, if the numerator is even, you will have to write plus or minus whenever you solve. And then we need to plug the answers back in to make sure they actually work. So if you plug in 11, you'll get 2 times 11 minus 3 raised to the 2/3 to see if that's 8. So 11 minus 3 is 8. 8 squared is 64. The cube root of 64 is 4, and 4 times 2 gave you 8, so it did work. Plug in -5. -5 minus 3 is -8. -8 squared is a positive 64 again. That's why it worked. And then the cube root of 64 is 4, and 4 times 2 is 8. So they actually both worked in this case. Again, if you have a rational exponent and the numerator is even, you will have to do a plus or minus. So let's look at this. Is the numerator even? No, so we don't have to worry about it. We can just take the reciprocal. The reciprocal of 3/4 is 4/3, which means we'll take the 4/3 reciprocal on the other side. So we'll get x plus 3 on the left. And this is the same thing as saying cube root of 27 raised to the 4th. Well, the cube root of 27 is 3. 3 to the 4th is 81. Subtract 3 and you will get 78 as your answer. And if you want to make sure it actually worked, plug 78 back in. 78 plus 3 is 81. The 4th root of 81 is 3, and 3 to the 3rd power does give you 27, so it worked. So let's do some practice. I would like for you to pause the video, attempt these problems, and then resume whenever you are done to check the answers. We have a square root on both sides. So I am actually just going to square both sides. And when I do, I'll get 3x equals x plus 6. Subtract x to give me 2x, and then divide by 2, and I get 3. And you can plug it back in to make sure it worked. 3 times 3 is 9. 3 plus 6 is also 9. The square root of 9 equals the square root of 9, so it did work. In this case, I need to get rid of the square root, so I need to square both sides, which means I have to quantity square the right-hand side. Quantity square. Don't just tell me that's x squared minus 1. It's not. You have to FOIL this. The left side becomes 3x plus 7 because the square root and the square cancel. Over here, you should get x squared minus 2x plus 1 when you FOIL this. This is x minus 1 times x minus 1. So I got to get everything on the same side, so I'm going to make it equal to 0. So I'm going to subtract 3x, and I'm going to subtract 7, and now I need to FOIL. This will be x minus 6 and x plus 1, which means x is going to equal 6 and x is going to equal a -1, and I need to check to see if these answers actually work. So I'm going to plug in 6, and I'll get 3 times 6 plus 7, and we want to know if that equals 6 minus 1. 18 plus 7 is 25, and 6 minus 1 is 5. The square root of 25 is 5, so that worked. Yay! So now we need to try -1. If we plug -1 in, -1 minus 1, we will get the square root of 4 equals -2. The square root of 4 actually equals 2, not -2. If you plug the square root of 4 into the calculator, you only get one number. You get 2. You do not get two roots. You only get one root, which is the positive. That is why this answer actually does not work. You need the positive number in order for it to work. In this last one, we need to get the square roots by themselves. You do not want to square both sides because you would have to actually FOIL this, because remember how we talked about you cannot just square this and square this part. You can't do that. You actually will have to get one of them onto the other side. So I'm going to leave the square root of 10x on the left, and on the right I'm going to add 2 square roots of 5x minus 25. Now I'm going to square both sides. Don't forget, everything on the right has to be squared, the 2 and the square root. That cancels, leaving you 10x. This actually leaves you with 4 times what's under the radical. So the square root and square cancel, but this square still has to make that 2 become a 4. So 10x equals 20x minus 100. Subtract 20x, you get negative 10x equals negative 100. And so x equals 10. And you can plug it back in to see if it works. 10 times 10 is 100. And then 5 times 10 is 50. 50 minus 25 is 25. So square root of 100 is 10. The square root of 25 is 5. 2 times 5 is 10. 10 minus 10 does give you 0, so it did work.